Welcome back. This is a recording of lesson 5.4, Solve Equations with Decimals. This lesson is part of Math 020 Pre-Algebra course taught at St. Louis Community College. The recording is made by Dr. Victoria Shearing. Lesson objectives, we only have one for this lesson, solving equations with decimals. When you solve equations that involve decimals, we're still going to apply all the same rules, all the general rules for solving equations, meaning that we will be keeping balance. Whatever we do to one side, we do to the other side. We're going to be using opposite operations in opposite order. So if you see that you adding a number to a variable, in order to isolate your variable, you're going to subtract that number. If you see that you're already subtracting a number from the variable, in order to solve the equation and isolate the variable, you're going to add. So you're going to be doing the opposite operations. Another one particular trick that you can apply when solving equations with decimals is that you can clear the decimals by multiplying the entire fraction by a power of 10. Remember when we recall from unit 5, lesson 5.2, we talked about multiplying by a power of 10, and all we do is we move the decimal point to the right. So I'm going to do it both ways. For part A, I'm going to do it as a traditional solving equation and as clearing the decimal point. Okay, so the first way is to solve it traditional way. I am going to isolate this variable z. So I have z plus 1.9 equals 12.41. That's my first problem. So I need to have z by itself. Right now, I am adding 1.9 to it. So I'm going to do the opposite, subtract 1.9. Subtract 1.9 from 12.41. So 1.9 minus 1.9, that gets me 0. So all I have on the left side is the variable by itself, z. And then I need to subtract 12.41 minus 1.9. So I have 1. Need to borrow a digit here. So I'll have 5. And then 1 minus 1 is a 0. So 1051 is my answer. 10.51. All right. So that's not a bad problem. Pretty straightforward because you had addition, you subtracted, then we used our rules that we learned in 5.2 again, how to subtract with decimal numbers, and got our answer. All right. The second method, how to solve the equation, I'm going to use it on part B and show you the second method, and then we'll go back to the first one on part B. All right, so here I don't really want to, it's more appropriate on the part B to use the second method. So I want to clear the decimal point. So that means I need to multiply the entire equation by a power of 10. Because the 12.69 has two decimal points, two numbers after the decimal point, that means that if I multiply by 100, I would have to move the decimal point twice, and I will have all regular numbers here. Okay. So let's go ahead and do that. Multiply by 100 times 100. So that means I have to multiply everything inside. So it's going to be 100 times W minus 12.69 times 100, or 100 times 12.69 equals negative 15.4 times 100. All right, so when I mean multiplying everything by 100, I multiply the entire equation, so that means I have to do it 3 times. I had W, I had 12.69, and I had negative 15.4. All of these got multiplied by 100. All right, so I have 100W. All right, so in order for me to multiply 100 times 12.69, I take the decimal point, move it twice. So now I have negative 1269. So no more decimal point in the 12.69 equals, and then negative, and then 15.4. I have to move the decimal point twice because I have the 100 two zeros. So 1540. All right. Yes, there are bigger numbers, but they're whole numbers. Okay. So what I'm going to do is now I'm going to look at my W because that needs to be by itself. So right now I am multiplying by 100 and I'm subtracting 1,269. So always start with the number by itself. And then you can divide by 100. So since I'm already subtracting, I'm going to add 1269. So add 1269. All right. So I have negative 1,540 and positive 1,269. Okay. Let me write this problem horizontally so we can see it. So we can see it better. All right, so what I have is negative 1540 plus 1269. Negative 1,540 is the bigger number, so the answer is going to be negative. And then I need to find the difference between 1540 and 1269. 40 minus 1269. All right, so I have a 1. I have 13 minus 6. That would give me a 7. 4 minus 2 is a 2. So 271. So negative 271 is when I added these two numbers, negative 1,540 and 1,269. Okay. So, all right. So I got that one, negative 271. So I have now 100W equals negative 271. My last step is divide by 100, both sides. And again, when you divide by 100, you take your imaginary, and like because this is a whole number, you take your imaginary decimal point and move it twice to the left. So the final answer is W equals negative 2.71. We started with the decimal numbers because we cleared the decimals, and then the answer is still a decimal number. So that is your final answer right here. So that is one way of clearing the decimals by multiplying by a power of 100. So you can work with whole numbers, which some students find easier. So we're going to go back and redo this whole problem with just the decimal numbers with the first method. Okay. So here we are traditionally, we're just going to go ahead and add 12.69 to both sides. All right, so again, let's write it out as horizontally so we can see what we're doing. So we're doing negative 15.4 plus 12.69. All right, so you're adding negative and a positive number. So the answer is going to be negative, and then we're going to subtract 15.4 minus 12.69. All right, so again, borrow a digit. So you have 3, 10, 1, borrow a digit. So now you have 13, 6, 7. Transfer your decimal point, and you have 2.71, and it's a negative 2.71. All right, same answer, two methods. Whichever one is easier. There is no benefit of one method over the other. It's a personal preference. Okay. So next one, part C, you have negative 0.016 plus K equals 0.08. All right, so divide it into the left side, right side. So kind of to remind yourself that whatever you do on one side, you do on the other. And then let's take a look at what is happening here. So I have a negative number here, negative 0.016. So in order for me to get rid of that number, I need to add 0.016. They're opposites of each other, meaning that there are the same numbers with different signs. So when you add them together, they add up to a 0. So I need to add 0.016 to the other side. So I will have, these two will cancel each other. So I will have k equals, and then let's go ahead and add our decimals. So I have the 6,900.096. Okay. So moving on to the next problem, you have 7 equals a divided by, or a over, negative 0.05. So remember that the fraction is the same as division. So fraction equals division. So you are dividing. A is divided by negative 0.005. So that means the opposite operation would be multiplication. So I'm going to do this. I'm going to rewrite this problem and rewrite, so a divided by negative 0.05. So because when we solve the equation, we do opposite, like the opposite operations of what's already there. Since we have a division, we're going to multiply. So I'm going to use a different color so we can see it a little bit better. So we're going to multiply times 0.05, negative 0.05. And then I'm going to do, you know what, let me backtrack there. I don't think I want to do that. So let's go ahead and multiply times negative 0.05. It's easier to see it that way. And then here, 7 times negative 0.05. All right, I put it over 1 because I have to multiply by a whole, by a decimal. So because I have a over negative 0.005 is a fraction, I'm going to write this decimal, negative 0.005, as a fraction, so by putting it over 1. And that way, you can clearly see that these two will cancel each other, and all I need to do is multiply 7 by 0.5. Okay, so I'll have a by itself on the right, and let's go ahead and multiply. So it's going to be negative. Then 0.05 times 7, so you have 35, and then 0, and then you need 2 decimal points, so negative 0.35. So that is the solution to this problem. All right. And then the last one here in this set, we have part E, negative 8W equals negative 72.8. So we have a multiplication already. So all we need to do is divide by negative 8, both sides. So let's go ahead and set up this problem. So we will have W on this side because the 8s will cancel. Negative divided by negative is going to be a positive number. And then we're going to set up the long division. 72.8 divided by 8. So 8 goes into 72 9 times. 72, all right. So we have a 0. In the end, we still have another digit, so we're going to bring the 8 down. So I can actually erase that 0. So an 8 goes into 8 exactly 1 time. To get to the 8, I had to step over a decimal point, so I'll place that in the answer, 9.1. So 8 goes into itself 1 time, and that is a 0. So W equals positive 9.1. And then I can get rid of this plus sign. That was just a reminder for me that I already decided on the sign and took care of the sign. All right, so let's see how many more problems we have. I think that's all we have. because then we're going to go into averages. All right, so one more example with a word problem. We don't have a lot of word problems in this course, but we have some. Mary bought 4 shirts for her son at a back-to-school sale. If she paid $17.52 total, how much did each shirt cost? So she bought 4 of them. So the total for 4 was $17.52. So we need to find the cost of 1. We're going to take the $17.52, divide by 4. All right, so let's go ahead and set up $17.52 divided by 4. Set up the long division. 4 goes into 17 4 times. Okay. So then 1 left over. All right, so we have 15 now. 3 times into 15, 32, and 8 times into 32. Okay, so 1752 divided by 4 gives you 438. So the official answer is each shirt was $4.38. This concludes the recording of lesson 5.4. Thank you for watching.